Meeting in a fortnight. I wanted to give you a presentation here on video format of the current SEMCOG models. This is based on a review Bill Davidson and I did of their models a couple of months ago and made a presentation on the same topic. Most of what I'm going to describe to you is their current model, which is contained in their so-called E5 documentation, which you have access to on their website. And my presentation is pretty much going to follow the table of contents in that report. Note that I've numbered the slides in the lower right hand corner so that as you're viewing these things and have notes or discussion items, we can get to this appropriate slide pretty quickly if you just preface those slide numbers when we get to Detroit. That said, I'd like to tell you a little bit about the chronology of the SEMCOG model before I tell you about its current grind. I actually got involved in modeling in southeast Michigan in the mid-90s when I was working on a major freeway reconstruction project. And back then the model was a daily three-step model, which omitted mode choice. And I guess that would be before enhancements, or the BE arrow that you see on the left-hand side of my timeline. In about 2000, SEMCOG took off on a rather ambitious model improvement program that you see summarized on this slide. I'm not going to belabor all of the points on all of these things because you can probably read this faster than I can recite it, but a couple of things I wanted to draw to your attention. One is the fact that the current model that's been operational since about 2009 is the so-called E5 version. There's an E6 version of the model, which you'll hear me talk about occasionally and a lot probably during the peer review panel meeting. That's a model update that Cambridge Systematics currently has going underway, work led by Tom Rossi, that should be done in January or February of next year. The other thing I'd point out is that in December of 2004, SEMCOG had a previous TMIP peer review panel meeting which, among other things, came up with a series of 20 major recommendations, most of which have been implemented. And I'll talk a little bit about that later, but suffice to say they've heavily influenced the E4 through E6 series of model enhancements. Furthermore, you might look down here at the lower right hand corner at the E6 improvements that are undergoing at this present time. A big part of that is their mode choice model redevelopment and development of time of day distributions and a movement towards, or at least an exploration of, destination choice modeling. So it's a big move over about a 12-year period to go from fairly substandard modeling, in my opinion at least, to best practice trip-based models. Another thing I should tell you a little bit about is the overall structure of the model so you get your mind around this. As you see there in the middle in baby blue, there's a fairly common four-step travel model on the demand side. Time of day is placed before mode choice, which is a little bit uncommon, but by no means a problem. In fact, it gives SEMCOG a couple of advantages that we'll talk about later. And working in tandem with this model is a rather innovative external and commercial trip model, again, which I'll talk about later, that all feeds into highway assignment. There's a feedback loop, and then they go into transit assignment. Finally, there's network summarization and the use of air quality models at the bottom end of the model. A little bit about the data is also a discussion worth having. SEMCOG has a lot of survey data, probably more so than a lot of MPOs that we've worked with over time. I've broken this down in kind of two categories of data: survey data and inventories. And the centerpiece of their surveys is the 2004 Michigan Travel Counts program, which was a statewide survey of about 14,000 households conducted by the Michigan DOT. In 2005, SEMCOG supplemented that with another 3,300 observations to add to the 2,040 that were included in the 2004 survey work. And the only real difference that I can see between the SEMCOG survey and the travel count survey is that SEMCOG did a 24-hour diary versus a 48-hour survey done in the travel counts program. And SEMCOG supplemented theirs with approximately 1,000 transit surveys to capture that mode of transport that wasn't terribly important to the Michigan DOT. As you can see, they've since then conducted more transit onboard surveys, a travel time database development, and now MDOT is looking at a new travel survey to supplement what was done earlier in the decade. They of course have access in the lower left-hand corner, as you can see, to other survey data that is available through national sources. On the inventory side, one of the things they've implemented that they've done a really nice job on is a network master, or a network database tool that is fed by the Michigan Geographic Framework, a statewide database developed by the Michigan DOT on the network side that provides a really nice tool for them to develop and maintain networks. They developed their own fixed route transit networks, and as you can see, they developed a couple of other databases, including a socioeconomic database that's based on a 2040 regional development forecast that's pretty recent. If you look back on the slide that shows the timeline progression of the model, you'll notice that they've gone from 2030 to 2035 to a 2040 RDF, and each point in time they've drastically improved the quality of the data that they're using for this. Their trip generation model is a pretty typical one. It has 6 trip purposes that are enumerated there on the right-hand side that they've estimated in the E5 model with data from the 2005 travel survey. And on the production side, they have a cross-classification model that's broken down between home base and non-home base trips. And as you can see, the former is based as a function of workers or persons by auto ownership, and the latter is based on different categories of employment and households. On the attraction side, they have district-based regression models and a fairly standard balancing process. Now, the one thing that you will notice that is not in this model is market segmentation. This is something that Bill and I picked up when we did our review, and it's important to note that although in the earlier models in their series they have almost no market segmentation, we'd like to see them do something based on auto sufficiency rather than ownership and on income, which of course would carry through the rest of the model. And in all fairness, the E6 work that they're doing right now will include some, but probably not all, of the market segmentation we'd like to see. But the previous surveys didn't really permit the market segmentation we'd like to see. Only with recent data have they finally caught up with that. Another thing that has been recommended by the TMIP peer review panel, and which we wholly endorse, is the development of a separate home-based university trip purpose, because of course they have some very different patterns. The 2 big universities in southeast Michigan are the University of Michigan in Ann Arbor and Wayne State University in Detroit, but there's a number of fairly large community college campuses sprinkled throughout the region, and we'd like to capture their unique travel characteristics. And finally, something that I've clued into is, and I'll talk about this in a little bit, is how much do these rates vary by county? We've always assumed that they're fairly homogeneous across the region, but I think that we have evidence now that that's probably not a lucid assumption and something we should maybe pay more closer attention to, especially in a region as diverse as SEMCOG. Their trip distribution is likewise what I would call a typical practice model. They have a gravity model. It's calibrated trip length frequency distributions. They use friction factors as opposed to a gamma function or something else like that, and it's based on weighted average travel times. They also use K-factors throughout their model. And as I showed you earlier, they use a feedback loop that would take the results of the model and feed it back into trip distribution. And again, I'll talk about this a little bit later on. Despite having a fairly standard model, I see some fairly puzzling results. Overall, for the region, they do a great job of replicating the average trip lengths and the shape of the trip length frequency distributions. And the interzonal trip percentages, they look real reasonable to me. But there are fairly large errors in the county-to-county workflows when I compare them to the 1990 or the more recent 2006 and 2009 3 and 5 year ACS journey to work data. And of course I don't really have anything to compare the other trip purposes to, so maybe the amount of error in those are a little bit worrisome. PB would like to see them incorporate composite impedance into the model. And it's important to note that another big recommendation that we've made to them is that they go to a destination choice model, and they're working hard on that in their E6 model estimation work. But I'd like to go back and talk a little bit about these work trips and the type of errors that we see in them, because they do feed back and they heavily influence the K factors in the model. And there's just something about me that just really dislikes K factors, and so I'm sort of keen to get them out of here. So when I look at work trips by district, this top matrix that you see here is county-to-county flows. With the exception of the first two rows and columns, Detroit is actually a subset of Wayne County. So the first row and the first column is the city of Detroit, and Wayne, that you see there, should say the rest of Wayne County. Nonetheless, if you get these 12 cells right that I've got numbers in here, you can sort of make the model sit up and do what you want it to do. For that contains 80% of the trips on a county-to-county level basis for the entire region. So the first matrix that you see there is from the survey, and the second one is from the model. And the bottom one shows the percent difference between these two. And as you can see, in a couple of cases they have pretty reasonable results, but in a lot of cases we see results outside the range that we would expect. I guess at some level I'm not all that surprised by this outcome, and to illustrate why, I need to take you to Baltimore temporarily. We're building a statewide model there, which really is a story of how Maryland or the Baltimore region interacts with the DC region. But as part of this work, a 2007 travel survey was conducted, and it included about 20 counties in Maryland. And we've grouped them into 7 categories. And here you see the home-based work trip length frequency distributions from the survey. The heavy black lines are the composite for all households in the survey, and each of the colored lines are the frequency distributions for the other 6 aggregations of, or I'm sorry, the 7 aggregations of counties. The really tall, narrow ones are the CBDs of Washington and Baltimore, respectively, and the relatively flat ones are the rural areas. And my point in showing you this is that we discovered in Maryland that you could get the CBDs right, or you get the rural areas right, but you really couldn't get the whole thing right with one gravity model formulation. In fact, if you take a look at it, this is one of the reasons I'm happy that SEMCOG is going to a destination choice model, and that on the left-hand side you can see the result of the district-to-district flows from the Maryland model using a doubly constrained gravity model without K factors, and we worked hard to get this thing to sit up and bark for us. And the green tiles that you see there are where the model and the data and the survey data more or less line up. Not much error. But the blue tiles are where we underestimated flows, and the orange and the red ones are where we terribly overestimated them. If you look at the graph on the right, you see what happens when we move to a destination choice model, and we're able to incorporate other variables that help describe travel within the region. I know this is not a surprise to any of you, but the model worked a whole lot better. You can see there's a lot of green tiles there. There's still a couple of problem children where we've under and overestimated, but by and large, we've got a very encouraging result, and I'm confident we'll see the same thing if we implement a similar sort of model at SEMCOG. So I'm jazzed about this and really want to see them move to this as fast as they can. Their external travel model is an innovative model, but it's based on some rather old travel survey data. I call it a best practice model because it has some really neat features. Not only do they have an explicit model of generation and distribution, which is not terribly innovative, but the way they do it is pretty interesting. They use link types as a surrogate for trip purpose, and they have 4 types: freeways, major arterials, minor arterials, and rural collectors. So for the trip purposes, on the production side, they of course are using a count at each of these external stations, which they then take out of trip generation, and the attractions are a function of the distance to the edge, from the edge of the network to the internal zones, and of course the internal attractions. They have a gravity model, which again is based on friction factors, which in turn represent the impedance of travel time. They overestimate trip lengths from between 7 to 62% depending on the type of link in there. And there's some reasons I can talk about later about why that is. And for the through trips in the model, they take that right out of the statewide model, which I'm a big fan of. And finally, once they have this daily distribution worked out, they just do a temporal distribution to the 4 time periods that SEMCOG uses from the count data. So that's a pretty reasonable model in my mind. For trucks, I say there's no standard out there because for the very few urban areas that actually do have a model, as opposed to a, say, 1967 trip matrix that's factored forward in time, they're all over the board. This is a fairly neat model in that it takes into account not only freight but all of the non-freight commercial movements within the urban area. And there are not too many models out there that do that. At the generation level, they estimate this beast at 248 districts, again a function of data limitations, but then they apply it at the TAZ level. They have 3 types of trucks, as you can see listed here, and their generation rates are a function of households, the size of the zone, and depending on the type of truck, employment by different categories. And it's not uncommon for truck models. You wind up with a statistically significant but not very inspiring statistical fit. This is not at all unique to SEMCOG. In fact, there's a fair amount of inherent variation in truck travel, as I think most of you know, and when you compound that with relatively small surveys, you're bound to obtain this result. When they go to distribution, again, gravity model using friction factors that represent travel time impedance, and they do a good job of representing the regional average trip lengths on the shape of the distributions. And then for the time of day distribution, they just take that out of the commercial vehicle survey. I can't see any evidence of where they use actual truck count data to do this. And as with the person external trip model, they take the through trips from the statewide model, which again I think is a great strategy. So for the truck model, as well as maybe for the external trip model, validation is mainly an exercise in replicating the survey from which the thing was done. There's no comparison to counts because they're relatively few, especially vehicle classification counts. And at least in the documentation, I don't see very many comparison to other models. And as I noted, this is a story about variation rather than central tendency, and the modeling approach we're using must be judged in that light. There's no best practice in survey methods, and I'm sure we'll discuss this at length during the meeting, but I don't see a lot emerging that really excites me. So some of the options for enhancement without data that I would like to see SEMCOG take a look at is maybe importing models from elsewhere. But a better idea in my mind would be to team up with CMAP, Chicago Metropolitan Agency on Planning, which is doing a particularly innovative job of developing freight models. And I like the fact that they're doing it on 3 levels: macro, meso, and micro. And I think that there's a lot that would commend that approach to SEMCOG. The other thing that I would encourage them to do is watch Sharp 2 C20 really closely. That's a project designed to develop and disseminate innovative approaches to modeling freight. Finally, I'd like to see them grab some counts. I think this is more important than grabbing survey data, and I would like to see that built up based on a network design problem where we find the most efficient place to have counts in the network from a model estimation and calibration standpoint, rather than just putting them out there wherever they happen to work the best. Time of day, very typical practice. From their travel survey data, they've got peaking factors and directionality factors. They're updating that to the 2005 survey in the E6 work that's ongoing. And it looks inherently reasonable when I compare this to other urban areas. Next up is mode choice. Fairly standard nested model. They estimated both multinomial and nested logit models at a good point of comparison. They used fairly aged data for the current implementation of the model. It dates back to the 1990s when they did the initial home interview survey for the E1, that I guess was E0 or BE before enhancement, as well as the E1 models. But they're re-estimating this part as part of the E6 work that is using much more recent data. In the E5, the current model, they've collapsed the trip purposes down to home-based work, non-home-based work, and non-home-based. A lot of this is based on data limitations. When we reviewed this, Bill Davidson and I were really interested in ensuring that they have consistency between the mode choice coefficients and variables and those used in transit path building. We didn't see that, and that's something we're really interested in seeing some progress on. When I look at the estimation results, they look, fairly reasonable. This is a little chart I pulled together out of the report that shows the model estimation. And I think that the point here is that within the constraints of the data that they have, they've got a fairly robust model. And we're happy to see that the work that they're doing to update this is going to, we believe, drastically improve it. When I look at trip assignment, on the highway side, I would say they have a best practice model. They use a multi-class static user equilibrium assignment that includes the purposes you see there. And one of the neat things about it is that their link capacity functions are based on the flow densities and speed flow relationships that you find in the 2000 highway capacity manual, rather than the default values that date all the way back to the Shirley Freeway in the late 1950s. And their general cost is a function that includes vehicle operating costs, the value of time, travel times, and a number of other link and travel characteristics that we think put it in a fairly advanced state. Great tool. Transit, on the other hand, is what I would call a typical practice model. Transcat Pathfinder in version 5, if you're familiar with that. Their generalized cost includes the variables that we would expect, and they have walk and auto access on both ends of the trip. Probably be difficult to improve on that without a major investment in travel survey data, and so we're pretty happy with that. The feedback mechanism is based on Sheffey's method of successive averaging. I haven't seen anything out there more sophisticated, and so we feel that this is excellent source of methodology for this particular step. When we look at the trip assignment, on the highway side, their regional traffic count database has about 100,000 observations in it that line up to about 6,000 count locations. So a very adequate sample from which to assess the model. Paradoxically, they have rather scant reporting in the E5 documentation of the daily results of the assignment process. They sum the counts and do a comparison by functional class and by county, and you can see the error ranges there. They're not bad. They're not great, but they're not bad. On the transit side, we have observed data that they obviously used in building this model, but we don't see what it is. And that's somewhat bothersome for us. And like traffic assignment, they have pretty scant reporting of data. And you see they have daily boardings by service provider that range from -44 to 30%. But the two big guys in the region have fairly reasonable data lining up with reality. Something we'd like to go back and explore a little bit further as the model development goes on. We'd like to see them report better validation, or at least more detailed validation summaries. And you can see here some of the statistics that we've asked SEMCOG to produce on a routine basis, and something that they're putting into their standardized reporting tool. Most of the documentation work that they're doing for the E6 is at the county level. And as they start looking at more detailed in E7 or whatever the nomenclature might be for their future models, we expect that they're going to have better data, both by which to develop and apply the model with, as well as on the back end here for its evaluation. Let me talk a little bit about the 2004 TMIP peer review panel. They came up with a lot of very good recommendations and very pragmatic. And as you can see, it's interesting when you get together with a peer review panel, especially one that leaves at the end of the second day and is able to leave the responsibility for implementing a lot of thoughts to others. And in my experience, I found that there's a lot of difference between peer reviewers and the folks that have to actually do the implementation. I've been really impressed with SEMCOG with the fact that they've pretty much bridged this gap that I often see in peer reviews. The 2004 panel had a number of recommendations that came out, and you see a long list of them here. There are 20 of them, and the number in parentheses after each of them is just the number from the report if you happen to have that thing open in front of you and want to refer to it. But they've implemented over half of the implementation of the recommendations, and they have most of those that are not implemented already underway right now as part of their E6 work. There's only a few things that they haven't really addressed, and two of them are fairly big blockbuster things. One is the move to activity-based modeling, and the second is to develop dynamic network models at pretty much the same level. They have not included non-motorized models, something that Bill and I think is fine to defer until they get to activity-based models. And there's a couple of minor improvements to the models that was a catch-all category. Some of them, like area types, which I've highlighted here, they've actually implemented, but there's a couple of others that didn't. Rather than listing it twice in the same area, I've just tried to show here that one particular thing might belong in several categories based on the progress that they've made. So when I summarize this thing, I look at it and say SEMCOG has a model that is somewhere between a typical and a best practice. They've got elements of both. It's a nice piece of work. It's a commendable job, and it's largely responsive to the peer review panelists that served them beforehand. Finally, I'll tell you a little bit about some of our initial thoughts about the model, not necessarily to influence you, but more to entertain and inform. A couple of things that Bill and I noticed when we went through this thing is we thought that market segmentation and the incorporation of home-based university trips would be an important part of the model. And indeed, that is a key effort underway with the E6 model development. The move to destination choice models, big part of my presentation, is also something that they're making a lot of progress on. We don't have results yet to take a look at, but I think they're going to be eminent. Bill and I guess I would say it's fair to say that we would have a slightly different approach to mode choice modeling. Rather than estimating the models from the survey data, we would have encouraged SEMCOG to spend a lot more time doing actual calibration of the model and looking at ensuring consistency between the transit path building parameters and the mode choice relationships, some of which they can still get to, some of which is probably precluded by the work they've already completed on the E6 model development. I told you a little bit about our perceived need to have comprehensive validation statistics, so I won't belabor that. Another thing that we would encourage them to do is to anticipate pricing. Pricing may be politically unpopular in Southeast Michigan, and indeed it may be one of the last places it gets to, but some of the rigor imposed in the model that would result from anticipating pricing and building the behavioral surfaces in there to accommodate it could only improve their model. I'm not sure that they need an activity-based model in the short term, but when we get to our discussion about their modeling requirements, you're going to see that they have a lot of traffic operations and what most people might call a micro-level set of priorities. The need to drive those kind of models with data from the regional model might take us most of the way towards activity-based modeling, as we would need a finer representation of time in the model and probably a better representation of destination choice. And when you start thinking about the things that you would need to feed a dynamic traffic assignment or a microsimulation, you get most of the way to an activity-based model. So oddly enough, some of their downstream requirements that require a dynamic network model is actually driving the upstream requirements to make them think towards moving towards activity-based modeling. But unlike a lot of places, I think that for SEMCOG, we're intent to recommend that they take a nice incremental approach to developing it rather than jump in with a large effort of their own. And finally, and this might be a little bit of a personal thing on the part of Bill and I, we try to get our clients recently to think wiki. In other words, instead of writing reports that document what a consultant did, maybe more so than what SEMCOG is doing currently with their models, we'd like to move them towards a wiki format, which is a continually evolving document that would help them not only inform the public about what they're doing, but perhaps reduce their overall cost of maintaining their documentation, both for internal use and for the model certification process that they're going to have to undertake with FHWA soon in 2012. And that's my story. If you have any questions or comments in advance of the meeting, I'd be happy to interact with you, but otherwise, I hope that this brings you up to speed as quickly as possible on the models without having to wade through a lot of maybe otherwise tedious documentation. That's it. See you in a few weeks. Bye now.